Welcome back, guys. In the previous lecture, we have started building our compiler, got familiar with the module, context, and IR builder, and also saved the empty module to file. Right, so here it is. And today, let's actually start optimizing our build system. Right, as we said, we will not be using build system, but we can save this command to a helper file, so we can use it from the editor directly. Right, let's call it compile and run. And exactly we copied the same command. Now, as we said, our compiler should produce the file, which is called out.ll, that is generated IR. And for now, let's use just directly interpreter, that is LI tool, which can accept the file and directly execute. Okay, sounds good. Let's try it. Okay, we need to make it executable, right? So change mode +X. Okay, try again. And it works. So we see exactly the same module, but take a look, we see some error, specifically related to the absence of the main function. Now this happens because we tried to execute the compiled LLVM module through the interpreter, and the first thing it tries to find is exactly the entry point, that is the main function. So this is the topic of our today's discussion. We'll talk about main function and about functions in general. Right, in previous classes we reached function compilation only in the later lectures, but in case of LLVM we have to start doing this right away, because without main function we cannot actually execute. Okay, so today we'll start building the step number 2, that is our compile method. For now we don't have AST, so we just directly will be returning number 42. Okay, so it looks like this. And let's introduce this helper method, compile. Right, I'm leaving to do to add AST here. And for now, let's just compile the main function, exactly the same code, which returns 42. So as we said, we need to have entry point, that is the main function, right? That's the first step. I will introduce the method called createFunction, passing the name. Then we have to compile the body of the main function, right? Let's introduce the gen function, which will be accepting any AST node and will be a recursive compiler, pretty much as interpreter, but happening at compilation time. That is the code gen. And once we have the result, we need to return it. However, notice that the return type of the main function is i32, so we have to explicitly cast. Our builder has the instruction called createIntCast. Right? Whatever result is, we're going to cast it to specific type. And also builder exposes different types. In particular, it has the method called getInt32type. Right? Ty suffix is exactly for types. And the second argument of this instruction is Boolean, whether the number is signed. Sounds good, we have the result, and now we need to create the return instruction. And for this we use the createRet method on the builder, passing the result. So that's exactly it. That should compile our main function. Again, we will introduce the createFunction method later. And now let's introduce our gen method, that is the code gen. And what is our main compile loop? We will start accepting AST nodes, that is expressions, in the next lecture, and today we'll just return unconditionally 42. Now the result of the gen function should be LLVM value. This is the very basic type which can accept pretty much everything. It might be numbers, might be strings, even instructions. So gen should return exactly the value, pointer to a value. And the simplest possible value are the numbers, integer numbers, for which we use the getInt32 method on the builder, passing the explicit number. In our case it's 42. Sounds good, and now let's add the createFunction method. And the return value here should be LLVM function. And at this point, we need to talk about functions in general, and then in particular about main function. Right, here's our diagram from the previous lecture. We said modules contain function definitions. So what is inside the function? In this example, we see the function, which is called square, which accepts only one parameter, also of type i32, and returns the value of type i32. That exactly we see in the return result, which is the multiplication of the x times x. So to create a function, first of all, we need to have the type of a function. What is the function type? Well, it's a type of its parameters and return type. Also, there is a special flag where the function accepts multiple arguments, right? So-called variable number of arguments. And then we said we need to compile the function body. Now, the function body consists of a set of basic blocks. Now, the concept of basic block in LLVM is very crucial, which is used in many different optimizations, and we can think about the block as a list of instructions. Now, a function always have the entry block, and in our course we'll be using the explicit label for the entry block, right? Each block has label, so this function should look like this, right? Entry. And in general, it might be just one block, or multiple blocks. Now, some blocks, as we will see later in this class, may contain so-called terminator instructions, such as branch, that is if-else, switch statement, return statement, which can transit to other blocks. Right? For example, here we see in basic block and specific branch instruction, which, based on the condition, can jump either to the basic block number 2 or basic block number 3. So this is, in general, what a function is. Again, an abstraction which has arguments, entry block, and multiple optional blocks. And once again, inside the basic block, there might be just plain instructions until we reach some terminator instruction, such as branch. If we met some terminator instruction, we have to jump to a different block. But these details are for the next lectures. So far, for the main function, we will have just one entry block. So our function should look like this. Sounds good. So let's switch to create function. And let's update our test file, right? It should look like this with the entry point. And also, as we said, to create a function, we need the name and also the type of a function. So let's accept the type as argument. And from our caller, when we call the create function, we now have to pass the type. For this, we use the function, which is called LLVM function type get, right? Which has multiple constructors, one of which accepts just return type. And we said it should be I32. And we also say we don't accept any of our arg. Sounds good. Now, also we need to say, when we talk about functions, we have function definitions and function declarations. Now, function declarations usually specify only the function header, that is the function prototype. What is the function prototype? Well, it's information about its type. That is the return type, parameter types, and the function name. So let's actually extract creating of the function prototype, that is its header, to a helper function. And also this prototype from other function declarations may already exist. Now, to check this, we can call the method on the module, which is called getFunction. And if it doesn't exist, first of all, we create the function prototype, passing exactly the same name as the function type. And now we have the function defined, we have to create its basic block. So let's create helper method called createFunctionBlock. And finally, we return the function. Sounds good. Let's start defining our functions. Create function proto. So it will be LLVM function create, passing the function type, the linkage. In this case, we pass the external linkage, that is, this function is visible outside. But please take a look at different linkage types in the documentation. For now, this is not so essential. Passing function name and the module where this function should be attached. Now, once the function is created, we can call the method called verifyFunction from LLVM and eventually return the function. Now, to call the verify, we have to include the module verifier.h, which ensures that we don't have any errors in our function. And finally, as we said, we need to create the entry basic block. Let's introduce one more helper method called createBB, that is basic block, passing the name, and we also may pass the parent object to attach to, that is the parent function. In this case, we exactly pass our function. And a very important point, the IR builder, that is the code emitter, works as a state machine. Now, once we allocated new block, we have to explicitly tell the builder to emit the code exactly to this block. So we call the method, which is called setInsertPoint, passing our entry block. Okay, sounds good. And now let's create the helper method for creating basic blocks. Again, we accept optional second parameter as the function where we need to attach. But sometimes a basic block should not be attached right away, as we will see when we'll compile an if expressions. And in that case, we'll need to add manually to the list of basic blocks. But for now, we just need to think as we create a block and directly add it to the function. And to create the basic block, we just call the appropriate method from the basic block class, create, passing the name and the function. Okay, so that should be it. Let's actually allocate the function which we created, right? Let's store it as a property on our compiler class, which is currently compiling function. And that should be pretty much it. Let's try testing it, execute. And there we go. Look at this, we now have the main function compiled and returned 42. And as you can see, my editor showed the error because 42 is not a valid return code. Right, usually we return 0, so 42 is treated as an error here. Let's slightly optimize our build script. So for this, we just need to print the result of the last command, as the result of the interpreter, which automatically will return 0 as the success code. And we will not see the error. Okay, let's test, and it works. Okay, let's add extra new line for convenience again. Include IOStream. Execute again, and nice and clear. So congratulations, we built the first object type, that is the functions, and also talked about basic blocks, entry points, and how we return values. And in the next lecture, we'll continue talking about functions, and we'll talk about external functions. That's it for today. Thanks, and see you in the class.